7, we are looking at a velocity time graph. And this is a very good question. I like this question, and this is where exam questions we'll look at as well. So what happens is a hot air balloon is going up. Okay, so you got to understand what's happening. And because the hot air balloon is going up at 10 meters per second, everything inside the hot air balloon is going up at 10 meters per second. So when an object is released from the hot air balloon, initially you would think that the object is just going to go falling straight to the ground. No, it's not. It's because everything inside the hot air balloon, if you were the person inside the hot air balloon, your shoes, your clothes, your hair, everything is moving up with the hot air balloon. So you're all moving at 10 meters per second upwards. So if you had an object that was with you, that will always be moving at 10 meters per second upwards as well. So initially, when you like let go of that object out of the hot air balloon, that will have an initial speed of 10 meters per second in the vertical direction. It's like you've thrown it upwards. Okay. So what's going to happen is that object is going to go up, slow down, slow down, slow down, come to a stop, and then fall towards the ground. Okay, so it's all because the hot air balloon was going vertically upwards with a speed of 10 meters per second. The object was also doing an upward motion of 10 meters per second. So when you release it, it moves up and it loses speed, just like if you throw a ball upwards and then comes down. And we can see that from the graph. We can see that from the graph that it starts off with 10 meters per second and it slows down to 0 meters per second. Okay, that is in the positive area of the graph. That means that from here to here, it is moving upwards. So that's the upward direction. The object is rising. Okay, then it comes to a stop here, and then it starts to fall and increases speed as it's falling, and we can see that speed is increasing as it's falling. Okay, so that's the understanding behind what this graph is telling us. Now, it says use a graph to show that the object continues to rise for a further 5 meters after it's released. So we know that on a velocity time graph, the area underneath the graph represents the area underneath the graph. It's to the axis, not everything here, it's to the axis. Okay, so that area represents the rising section of the ball. Okay, so when does it stop rising? Is when its speed is 0. That's right at the top of the rise. And so we are looking at this area here. And that's a half times the base times the height, half times 1 times by 10, which is 5 meters. Okay, so that's the rising section. Determine the total distance traveled by the object from when it's released from the balloon to when it reaches the ground. So here we know that the ball reaches the ground, okay, at this point after 4 seconds. Okay, so that's in the graph shows how the velocity of the ball object varies with time when it leaves the balloon to when it reaches the ground. So when the line stops here, we know that it's reached the ground here. So we're going to work out this area to find out the distance that it traveled there, which we already done. And then we're going to work out this area here to find out what's the distance traveled from 1 second to when it hits the ground at 4 seconds. So it's a half times 3 seconds, because that's from there to there, times by the that there, which is 30. So half times 3 times 30, which is what I've done here, is equal to 45 meters. So we know that the ball traveled 45 meters upwards, then it traveled 45 meters downwards. Okay, so 5 meters upwards, 45 meters downwards, and that's a total distance traveled of 50 meters. Add up the areas. Now, the next question is a very good question. I like this question. I think this is my favorite question in this homework. Now, we know that the ball goes 5 meters upwards. So this is the point of release. We know that it travels 5 meters upwards, slows down to zero speed, and that drops to the ground. There's the ground, and it drops another from the top of the maximum height. It falls 45 meters to the ground. Okay, so it climbs 5 meters, then falls 45 meters. Okay, now what is the displacement? Displacement is the distance from the point of release, the starting point, okay, to the ground. So this is the starting point. That distance there is 5 meters. So we know that from the starting point to the ground, it's 40 meters. Okay, so it's gone 5 meters upwards, then it's done 5 meters back down to get to this position where you threw the ball, and then it drops another 40 meters down. Okay, so that's a displacement of 40 meters. So what is displacement? Is the direct distance from the starting point to the end point. So that's the direct distance of 40 meters. Now that will pick you up 1 mark. However, you need to put a negative sign. Why? Because it's downwards. Okay, it's below your starting point, so that's negative. Above your starting point, displacement is positive. Below, negative. Okay, same with velocity. Velocity upwards, positive. Velocity downwards, negative. Acceleration upwards, positive. Downwards, negative. Okay, so it's minus 40 meters. Okay, so it's from the starting point to the end point, the ball has gone a minus 40 meters displacement. Now the next section, we know we have to plot a acceleration time graph of this journey. So we look at this, it's a velocity time graph. We know the gradient represents the acceleration. The gradient is constant throughout the whole 4 seconds. The gradient is constant. Okay. And the gradient is, and we work it out, the gradient is the height, the rise over the run. Okay. We know that is a negative gradient, so that should end up being a negative value. So I've worked that out. Here, the gradient is the change in velocity over time. The rise is minus 30 minus so its final speed is minus 30 minus 10 is initial speed. So that's minus 40 divided by 4, and that gives us minus 40 over 4 minus 10 meters per second squared. There's a mistake here, that should be a 2. So we know that the acceleration or deceleration, acceleration, it's in this downwards direction, minus 10. We know acceleration due to gravity is downwards, so that it does make sense. But it's constant for the 4 seconds, so it's a horizontal line all the way to 4 seconds. So what do you get the marks for? The horizontal line, 1, the minus 10. So you draw the horizontal line underneath in the negative section, and the line stops at 4. Okay, that there is the graph. You could, if you want to, put a vertical line here in this direction going to 4, but it's up to you as because that's when it hits the ground. So this acceleration drops to 0 at that point. But G is G at the end of the day. So you can leave it at